Hello everyone, welcome to Google Cloud Run Serverless tutorial. So today we'll be going through the Google Cloud Run, which is the serverless containers. So let's get started. Now, Google Cloud Run runs on the world of containers. So everything should be containerized and then available as a service. So it's similar to like if you have worked with Docker, Docker Swarm, or Docker Compose, Kubernetes. So it's almost 80%, 90% similar to that, and uh, rest comes with Google as other kind of services. So we'll go through one by one. So let's get started and understand what are serverless containers. So Google Cloud Run provides the way of managing the serverless platform by use of containers and and use of particularly Docker containers. So it is fully managed serverless platform for developing and running web applications using Docker containers. So whatever you have here, you have the flexibility of choosing the favorite language or whatever language you want to have your source code and build your application. You just need have the requirement to containerize your application, and the rest will be taken care. So container image here, one more we have the requirement is like it should be serving as a web server, and the memory and CPU requirements should be defined here. If not, it will take the default ones. Rest it will be taken care by the serverless mode of the Google Cloud Run. So whenever you create a web server, it will be having some HTTP endpoint, some handling part for the requests, and the rest for managing the containers will be handled by the Cloud Run. The Cloud Run is very easy when you compare it to Docker or Docker Swarm, and very easy compared to the Kubernetes architecture. Now here there are no such architectural restrictions like Google Cloud Function or Google App Engine. So you are not bound to a particular global cloud provider like Google. So you can basically just have your application Dockerized, and once it is Dockerized, you can you can have you can host on separate platforms apart from the Google Cloud Run. You can also use on your on-premise or on your also on your local machine. So there are actually two options which are available in the Google Cloud Run. One of them is fully managed environment, that is the Google Cloud Run. The other one is uh, the Google Kubernetes cluster. So you can have the same Kubernetes cluster here also in the Google Cloud, and you can follow that model. Coming to the GCR now, what are the merits of this? It's going to make the life simpler, because once you containerize your application or the source code, so there is no such dependency on any such platform, and also it can be run anywhere, and no one can complain like it's running on my machine and it's was running on this server, that server, but not running on another server or another platform. So those things vanishes. Away. Now, the only thing to note here is like this is a stateless web application. So, what stateless web applications mean here is like the state of the application is not stored. So, once suppose you're using the application and you do some activity, and just after completing the activity, it takes around 2 to 3 minutes, and you come out of the application. So, next time you logged in, your states will not be stored here. This is what they mean by the stateless web application. Now, the auto scaling is very good here, and it's quite easily managed here, and billing flexible, and all facilities are again same as of the serverless mode. This testing is extremely simple here because of the containerized world here, and we just need to use the same container and deploy anywhere we want, and we can test it similarly. Portability is, as we already discussed, like now containers can be run anywhere at any time. No, there is no such dependency of the platform or OS or any other thing. As long as you just meet the basic requirements, everything would work fine. It can only serve as of now, like Google Cloud can only serve as a HTTP request only, or some push based events on the cloud, on the pub serve, and on some processing of the storage events. So this is these are the merits of the Google Cloud Run. Let's go through the demerits now. the most important, I see the point here is like it is in the still in the beta phase. So this means that there will be, or there may be some major changes till the final version is rolled out. So we need to be careful about that. And the other one is the applications should always be running on 8080 port. This is the major restriction here. And as we can say that exactly it's not a serverless model as compared to the Google App Engine or the Google Cloud Function. Because here we need to have more code ownership. So everything as in the Google Cloud Run, everything is deployed as a service. So various services are linked together. Whereas in Google Cloud Function or Google App Engine, everything is working independently. They are not dependent on other things. But whereas in the Google Cloud Run using the services part, everything is linked here, and we need to have the more code ownership, and we need to think whenever we need to change some service, we also need to take care of other services or the other dependencies on it. Uh, Now, Google, let's go through the Google Container Runtime Contract, which is published by the Google. So the container must be compiled with Linux 64, Linux 64 bit, and but it can use again use any programming language of your choice as long as you are able to Dockerize it, and you can use any base image of your choice. Now the container must again this is the same point here which we covered earlier. The container must be running on 8080 port, and it can serve only HTTP requests. Then the container must start the HTTP web server. So container should always have a web server, and which should start within 4 minutes, so that it can be able to receive the requests. These are the requirements or the contract defined by the Google. So if you don't follow it, you may face a lot of issues, or your application may not be stable. The container file system is an in-memory writable file system. So anything you write may not persist, and it will persist as long as your Docker container is running. Once it is stopped, you'll not able to get the same state. So you need to think on it. If you want to have some volume and other things, you should map it to some storage for those things. Resource allocation of the container. Now, these are the default parameters which will be given to your Google Cloud Run applications if you don't mention the CPU and memory for your application. So by default, it will be allocating one virtual CPU for each container instance. However, you can run, however, the instance may run only multiple cores at the same time. So by default, one container will be using one vCPU, but you can run as many instances as you want. And also the containers can be run on multiple cores at the same time. So you can utilize separate cores at the same time. Memory by default is 256 MB of memory is allocated, but you can again increase it up to 2 GB. Now these are the below points are for the free quotas monthly quotas. So CPU is allocated 1,80,000 virtual CPU seconds. Up to this it will be free, and after that if you cross this limit they will charge. Memory is again double of the CPU, that is 3,60,000 GB seconds, and the first 2 million requests are free, totally free. So this should be enough for any project team or the development team or individual start or individual owner or any startup for to get started and use the service, because this is like quite good a limit amount for you to test your project or have an MVP plan ready with the project with these limitations or the quotas. Now, networking is the first GB of egress traffic, that is the outgoing traffic, is free. After that, they will charge you. Google Cloud Run on again GKE, the Kubernetes cluster and all. If you use, they have a separate pricing model which will be announced before the service reaches the general availability. Thanks for joining for the theoretical session of Google Cloud Run. In the next lecture, we'll get our hands dirty